Look, what is it? Another loss, but this time cost a bit more. For what? This is what we paid for our powerful computer last year to train and deploy our machine learning models. But since you remember we moved to cloud and I'm now using Azure Machine Learning for doing so, it is now totally useless. That's not true. Moving to Azure and Azure Machine Learning doesn't mean that your current on-prem computers are useless. You can actually attach your computer to Azure Machine Learning through Azure Arc to use this attached computer as a compute engine to execute your workloads, let's say training and deploy models, and have a hybrid MLOps solution both on-prem and cloud. Can you repeat again? Sorry, I'm lost. Okay, I said you can attach your computer to Azure Machine Learning.
Oh, I got it.
By saying attaching my computer to Azure Machine Learning, I need to pack my computer and ship it to Azure data centers so they can attach my computer, right? No? This is what I thought. Sorry. I was joking. You know what? Actually, it's much easier to show you how you can attach your computer through Azure Machine Learning through Azure Arc, right? Let's check it out, okay? Let's go. Hello everyone, welcome to another MG video series which is going to showcase you this time how you can attach your on-prem Kubernetes cluster as an attached compute to Azure Machine Learning through Azure Arc, which enable you to have a hybrid machine learning operation solution. That means you can even execute your training code or even deployment process on your attached compute, which is on-prem, but now this time attached to Azure ML and managed end-to-end by Azure Machine Learning. Let's check it out. Before we start, make sure you subscribe and hit the bell icon so you will get notified for the next video. Thank you. So first of all, let's start with what we are going to achieve through this session. So on the right side, if you follow up my pointer, this is typical machine learning steps through Azure Machine Learning that we build models, we build the environment, training on the top of that environment, validating the models, deploying and monitoring through CI/CD pipelines, so on and so forth. And within each single step of machine learning through Azure ML, you might have different computes. Let's say you might use a GPU machine for training your deep learning models and a CPU cluster for, let's say, deploying your models, right? One of these compute types that you can leverage within your machine learning process can be an attached compute to Azure ML. Of course, we have seen compute instance, compute clusters that you can create in Azure ML for whether deploying or training your models. But also, if you have other compute engines out of Azure ML, you can attach them. If you have seen previous videos, we have, let's say, attached Databricks cluster to Azure ML to be able to actually utilize the power of Databricks and offload our execution to Databricks from Azure ML. Here we are going to do something similar, but this time what we are going to attach to Azure ML is a compute engine that we have on-prem. Let's say you have a Kubernetes cluster running on your computer that you have on-prem. You have purchased a powerful computer and you're running Kubernetes clusters there. You can attach them to Azure ML and treat them as something that you have like other computes in Azure ML, like compute clusters, right? So you can execute your codes there, train your models, deploy your models using the compute that you have out of cloud, which is on-prem. So in order to do so, as you can see here, we need to have Azure Arc created in Azure portal. I'm going to show you how we can create that and attach our Kubernetes cluster through Azure Arc. And as soon as Azure Arc shows the Kubernetes cluster that we have on-prem, then Azure Machine Learning can find it and we can attach to it. Not just for on-prem clusters or Kubernetes, even if you have Kubernetes clusters on other cloud providers, let's say Google Cloud, GCP, or AWS, you can attach them through Azure Arc, and then Azure ML can connect to them and execute the codes there, and you can have a hybrid machine learning operation through multi-cloud environment or even your on-prem, which is a great benefit that we can leverage here. So let's investigate a little bit more. Before we start, what would be the benefits and what are the patterns that we need to know when we connect our on-prem, let's say Kubernetes, to Azure ML? Well, let's say, if you follow my pointer, let's say the location of your data is on cloud. So certainly you can use Azure ML on cloud-based Azure ML computes, like instance clusters there to train the models. But when you want to deploy the model, you can deploy to your on-prem Kubernetes, which is attached to Azure ML. Why? Let's say model must be deployed on premises because of security, compliance, or latency requirements. So you have an option here. Or if the data is on-prem, you haven't moved your data to cloud, and you don't want to move the data to cloud, or data must remain on premise due to residency or data residency or other requirements, then that's fine. You attach your on-prem Kubernetes to Azure ML. So when you execute the training code, for example, your Kubernetes is on-prem, your data is on-prem, the training can be happening when you are in Azure ML. So the order is got from Azure ML and the execution part is happening on-prem, because on-prem facility and execution compute is attached to Azure ML. And then let's say if you want to deploy the model, then you can deploy it on cloud to have the elasticity and scalability capabilities on cloud. Or some other scenarios here. If everything is on cloud, you don't need to leverage your on-prem Kubernetes, that's fine. You can have your end-to-end MLOps solution on cloud. Or if the data is on-prem, you want to train the model on-prem using your attached compute, which is on-prem, and you can even deploy it from there. So you can have fully automated MLOps all end-to-end on-prem or on cloud, or the combination of those two that we discussed. And here are some requirements for implementing and the motivation behind why we need these configurations. All right, let's start. Let's see how we can connect our on-prem Kubernetes to Azure Arc, and then Azure ML can use it to, let's say, train a model. So of course we need to have an on-premise Kubernetes to start. In order to simulate this situation, I created a virtual machine assuming this is my on-prem. Of course this virtual machine is on cloud, but just let's say that this virtual machine is a desktop computer that you have, and you have Kubernetes running there, right? So I needed to have that environment and install my Kubernetes cluster. So as you can see, here's, let's say, is my on-prem, assuming this is my on-prem compute. This is a virtual machine. I name it as K8S. So let me connect to that and we log in and see how I have created a Kubernetes cluster, and then let's do the attachment. All right. This is the virtual machine, but again, let's assume that this is my on-prem resource. This is my desktop machine that I have on-prem, and now I want to have a Kubernetes cluster here. So of course there are multiple ways that you can create a Kubernetes cluster, but here I'm using Docker. And if you just simply install Docker, here I installed it for Windows. If I go to settings, there's a Kubernetes tab here. If you click on enable Kubernetes, it will automatically start a Kubernetes with just a single node cluster. And please make sure that you at least have 4 cores for the machine that you want to attach, because some of the cores and capabilities of your on-prem resource will be dedicated to install some specific extensions needed to be connected to Azure ML. So if you have lack of memory or cores, that wouldn't be that much feasible to attach your on-prem Kubernetes to Azure ML. So after clicking on that, I applied, and then I saw that there's a Kubernetes running for me, all end-to-end. So perfect. I gave it a name, and here's my Kubernetes running right now. So now I have my Kubernetes. Very simple. I need to connect to Azure. I need to attach this to Azure through Azure Arc. Then of course we need to create an Azure Arc service here, right? So if you just type Azure Arc, you will see here, you can click on it and create one. Let me show you how I did. So you just click on the Azure Arc and then you can see Kubernetes clusters. You can click on it, then you can just simply add a cluster. Let's do it very quickly. So go to cluster details. You certainly need to fill all this information, and this is actually the place that you need to give a name to your on-prem cluster that you're attaching it through Azure Arc, and then clicking on tags. If you want to add anything, you're gonna skip. This is the cool part, that you need to actually execute this code to attach your compute cluster or Kubernetes cluster to Azure Arc. So you need to log into Azure, and then you need to set your Azure account to the subscription that we have Azure Arc running, and then using this command line you will connect your on-prem cluster to Azure Machine Learning, so Azure Arc. And of course this resource group name is mine, this is the location of mine, that's the name of the cluster. Yours might be a bit different, but actually because we want to connect that cluster for being connected to Azure ML, we need to add some more specific configurations here beside these ones. So I'll come to this, but as of now, the very first thing that we need to do, of course, we need to log in, and these should be executed on your on-prem machine. So let's go to our, let's say, on-prem Kubernetes cluster running, and let's execute this. So coming back here, the first thing I should do AZ login. So for doing AZ login, if I just hit AZ login, it will ask me to authenticate to Azure portal through using my credentials, user and pass. But the other way that you can do is also log in through service principal. If that service principal that has enough permission for attaching a compute to the Azure Arc, you can use even that service principal to get authenticated, which is the way that you can do. You can say AZ login, give the Apple application ID of service principal, the key that you have generated for that, and the tenant ID, and that's it. You will log into Azure. And then if you remember, the next thing that we should do, we should set to the current subscription using your subscription ID here. Coming back, then you would say, let me actually copy that. I'm not going to execute it because I already did this, but I want to show you how I did before recording. And that's it. You hit this, and then you will come to the latest one, which of course we need to a little bit change it before we execute it. So by mentioning change, I mean we certainly need to execute this, but following up on this code line, we need to add some more specific extensions. So let me copy that. Coming back to our environment that we have our Kubernetes running. Sorry, I executed so many codes before that. Let me just maximize it. Okay. Let me remove this code. And assuming that I'm gonna execute this, but again, I did it before, just show you how I did. So there you go. AZ connected K8s, connect the name, of course, the name of the cluster, the resource group that we created, and of course the location on Azure. So after executing that, what will happen is if you go to here and click on verification, you will see that it is verified and your Azure Arc will know that you have a Kubernetes cluster called test that is attached here. If I go ahead and do that, it says that, oh, we couldn't find because it didn't execute the codes. But because I already did already create an Azure Arc and executed the codes, I'm gonna show you how it's gonna look like when it's verified. As you can see, I did it yesterday. So Arc 3 is the name of the cluster that I chose. If I click on it, you can see it is telling me that, oh, it is already connected and it seems to be healthy. I have done everything properly. But does that mean that now we have connected my on-prem Kubernetes to Azure Arc, now we can use it in Azure ML? No. There is just one single step left that we need to do, which is installing the extensions of Azure ML on our on-prem Kubernetes to make sure that can be used for Azure ML purposes. How we can do it? There's one command line left. And this is the code that we need to execute. So we already did this. This was the last thing that we did. And now this is the last part that we need to create the extensions of Azure ML in Kubernetes cluster. So if you just launch PowerShell in the machine that you have Kubernetes, you say K8s extension create. This is talking about Microsoft Azure ML Kubernetes configuration, enable training true. So we can do the training, let's say, of models over these Kubernetes. And the cluster name, I chose Arc 3 or test, whatever you have chosen, just add it here. It might tell you again that, hey, I need to know the resource group name. If yes, it happened for you, you just also add resource group name, space, and then put your resource group name. That's it. So this is again the place that I have Kubernetes and I need to execute the code that I just showed you. I wouldn't, because I did. After executing that final code, this is what will happen if you go to Docker. So this is my Docker. Let me go to home. And if I go to containers, you will see that these containers will be, some of them related to AML will be happening, created here. You can see some of them running based on the latest time that I executed some commands. It shows that when was the last time that they got started and what is the status. So all of them got appeared here for me. I did nothing, just executing that final code that I just showed you. Now Azure ML can find this Kubernetes from Azure Arc. So let's do that final step. Let me go to my Azure portal, and this is the Azure Machine Learning that I want to attach this on-prem Kubernetes here. So let me open this. There you go. I'm loading my workspace. So if you go to compute, these are the compute instance and cluster that will be created on Azure. But if I want to attach my on-prem cluster, this is how you do. Go to attach compute, click on new, Kubernetes, and you give it a name, test 1, 2, 3, whatever. And then remember, I already connected my on-prem Kubernetes and I gave it a name which was Arc 3. It appeared here. I just click on it and click on attach. I already did it before. You can see I did it yesterday and successfully attached my on-prem Kubernetes to here. This is awesome. Now actually let's give it a try. I want to train a model. In Azure Machine Learning, I want to create a job that train a model, but I want to use this on-prem Kubernetes to train the model. And let's see how it's gonna work. But just being in Azure ML and do nothing in on-prem, okay? So there's a concept called jobs in Azure Machine Learning. If I click on job, I can see the latest job that I already executed. But in order to create a new one, I can just click on create a job, and here I can say what is the compute that I'm gonna create this job. Of course I want to use that on-prem Kubernetes, so to attach one, Arc 3 is my attached Kubernetes cluster through Azure Arc, and let's keep one as is, instance count 1. Let me click on next. Here you can choose the environment, the image that you want to deploy and train the model. Deep training the model, which what we're gonna do through this job. You can use the created ones. Each of them, they have different packages already installed, but I already have mine, which is custom environment MG. I can expand it to give you some more info. There's just only one version of this environment, and I can show you what I added. There are some packages of scikit-learn, let's say pandas, numpy, that I need to train. Just a simple machine learning model using scikit-learn. So this package is already inside this environment. That's why I'm choosing it. Clicking on next. So that's a random name. You can change it. Change the experiment name if you want. And you can upload the file to execute it, or a folder with multiple files. Here, I just want to upload the train.py to run it through on-prem Kubernetes cluster. So let's see what is my training code. This is the training code that I have. These are, as you can see, the packages needed. I added in my environment, and this is the main function that get executed as soon as I execute this code. And you can see with MLflow autolog, I'm logging all the metrics that getting created when I train the model using this code. Okay, so I have the data set here to split it to train and test. I am actually using the very well-known MLIST popular data set for training this simple model using scikit-learn. And you can see that after training the model, I'm calling it train model function, which is already here. That training a logistic regression, fit the model and train and test untrained data set, and then return the model. And of course, there are some pre-processing happening, scaling, reshaping the images from 2D to 1D, so on and so forth. So regardless, that can be anything, but that's just a simple example coming from GitHub, and I'll add the link of that to the video description. So that's, I call it main.py. So you can just upload this through here or from Azure ML default blob storage if it's there. So for me, it was already on-prem, so I could upload it from here with browsing my computer and saying that just run this Python code, which is Python main.py, which is my code. And that's it. If I click on next, there are some specific more configurations, input and outputs. If you want to have an interaction endpoint, let's say Jupyter, you can add it here. But for me, I just want to execute that training code that I'm uploading here, but running on a Kubernetes, which is even not here. It is on-prem, or it's in another cloud. Let's say it's on AWS, right? And that's it. If I click on next, it will create one and execute it. I already did all these configurations here, and I ran it before. It took me 4 minutes actually to do it. So let's actually do it again and see what's gonna happen. If I click on edit and submit, you can see that the Arc tree is the one that I chose. The environment is the same, and I already uploaded main.py. I want to run this. Nothing else, no specific tags. Clicking on next. So what I'm gonna do, I want to run this training code main.py that I showed you here over an on-prem Kubernetes that I already attached to Azure ML. That's all. Clicking on create, and let's see what's gonna happen. So let me go to job details. You can see it's queued, so I'm gonna pause the recording and resume recording when it's done. Actually, before pausing the recording, since we are waiting for this, using job was just one example of what you can do with attached compute cluster in Kubernetes. You can even use designer or pipeline in Azure ML. Let's say here is the sample of Azure ML for training a regression model that predict the price of an automobile. If I want to execute all end-to-end this training and scoring pipeline, I can run it from here to my on-prem attached Kubernetes cluster. How? If I go to job overview, oh sorry, this is the jobs. I have to go to draft one. So let me go to pipelines, my draft that I was playing with previously, and there you go. So this is my model pipeline. Clicking on settings, here you can say that, hey, run this end-to-end pipeline not on compute instance or cluster, to my on-prem Kubernetes cluster that I have attached. And if I click on submit, this end-to-end will be executed in my on-prem Kubernetes. But I'm not going to do that because we already submitted a job to on-prem Kubernetes. So let's see first if it's gonna get finished. So going back to my jobs, you can see there's one running right now, which is running on my Arc tree, which is an attached compute cluster, Kubernetes cluster. And let's see when it's gonna be finished. But I want to show you actually something cool since you're waiting. So let's see what happens when we execute this code to on-prem Kubernetes. Let's monitor that Kubernetes cluster and see if there's really, let's say, a spike in the CPU that is really actually working and doing something. So going back to my, oh, I have to log in again. All right, this is my Kubernetes cluster on-prem, right? So with executing the command line docker stats, I can see the status of my Kubernetes, right? So docker stats, and what is this? This is actually coming from here, which is the idea of basically my containers running on Kubernetes here. So the one that I copied is the one referring to training. Why? Because I'm training a model using that. So there you go. So you can see here I ran the job again, and just less than a minute ago some more containers got just launched. I did nothing here. I just actually ran the job from Azure ML and I got to my on-prem Kubernetes and I saw them all running. So if I actually check this training cluster, let me copy this and do a docker stat check. So I'm gonna paste it here to check how that Kubernetes is actually working and do the training for me. Hit enter. There you go. We can see CPU 83, 96. Perfect. That shows it is actually doing something, which is running my training job from Azure ML that we executed to this compute Kubernetes cluster, which is on-prem and is attached to Azure ML. So it should take like 3 or 4 minutes because I did it several times before recording and even now. So I'm gonna pause recording and quickly resume again when this one is done. So I just saw that actually the CPU percentage got to 0. So I assumed the job is over because that cluster is doing nothing. And then when I went to Azure ML, actually let's do a quick refresh. There you go, it's completed. So that's why it's stopped working. And let's see what is the outcome. If I go to outputs, I can see the model. There you go, the pickle file of the model, all those requirements, the YAML file. What we have even actually logged through that execution now has been shipped to Azure ML, and I did nothing in Azure ML. I executed the training code to my on-prem through that attached compute cluster. So let's check out the metrics. You can see even the metrics because of mlflow.autolog that we had in the code. We have the metrics of the model. Let's say the F1 score accuracy and all those components has been shipped and logged for me. Even I can check more. I can have them through table. And if I go to images, there's actually a confusion matrix that has been generated for me. Again, everything happened to my on-prem Kubernetes. But all end-to-end managing Azure ML, I even didn't need to open this on-prem, let's say Kubernetes, and do anything here. I just wanted to show you when you actually run what happens. Some containers get launched and you can see 5-6 minutes ago they got started. And again, you can do it also for pipelines. You can execute the pipelines in attached compute cluster. And here in this article, which I'm going to add the link of that to the description of this video, shows all the steps that I just did to be able to do that and attach my cluster Kubernetes to Azure ML. So you can follow this. The execution codes that I explained, they're all here. And here are the scenarios that from Azure ML you can execute the jobs, all these specific components to your attached Kubernetes from Azure ML. And again, I'll add this to the video description. That's all. Stay hopeful. You never know what tomorrow may bring. See you next week. Stay hopeful.